Astronomers have spotted something truly bizarre: enormous, ghostly radio rings in deep space that don't match anything we've seen before. These mysterious formations, called odd radio circles, ORCs, span millions of light years and appear only in radio waves, leaving scientists puzzled. In this video, we'll uncover how they were discovered, explore the leading theories, and reveal why these strange cosmic rings could change astronomy forever. The story of odd radio circles begins with an unexpected twist in the EMU survey, the evolutionary map of the universe, carried out with the ASKAP radio telescope in Australia. During deep sky imaging, astronomers noticed faint, almost perfectly circular features that did not match any known category of astronomical objects. These weren't just odd blips or distortions. They were stable, ring-like structures, bright along their edges and faint in the middle, spanning roughly 1 arcminute across the sky. What made them so puzzling is that they appeared only in radio wavelengths. When researchers tried to cross-check with optical telescopes, infrared surveys, or even X-ray observations, there was often nothing to be seen. This absence of counterparts in other wavelengths immediately set them apart from familiar objects like supernova remnants, planetary nebulae, or star-forming rings. In short, these circles didn't fit into the cosmic zoo we thought we knew. Initially, some astronomers wondered if these circles might be artifacts of radio imaging or data processing errors. But that possibility was quickly ruled out. Teams verified the findings with multiple instruments, including the Australia Telescope Compact Array and the Murchison Wide Field Array. Each telescope confirmed the same circular features, solidifying them as genuine celestial phenomena rather than false signals. Over time, more ORCs began to appear in survey data. In fact, a 2025 study applied advanced object detection algorithms across EMU's first-year dataset and identified 5 new confirmed ORCs and 2 promising candidates, nearly doubling the known sample size. The same study also introduced a related group of objects dubbed glares, or galaxies with large-scale ambient radio emission, which may be connected to ORCs in evolutionary stages. So what exactly are these massive radio circles, and what might they represent? That's the big puzzle, and scientists have proposed several leading ideas, none of which fully solves the mystery. One of the strongest candidates is that ORCs are giant shock waves triggered by past galactic activity. Imagine a galaxy with a supermassive black hole at its center going through a violent outburst phase. When material falls into the black hole, it can shoot out enormous amounts of energy, driving winds and outflows into surrounding intergalactic space. Once those winds shut off, they can leave behind expanding shock fronts, like ripples spreading outward in a pond. Observations of one particularly detailed ORC, known as ORC J0356-4216, revealed 2 symmetrical rings stretching over 2.18 million light-years across. The polarized radio emission showed magnetic fields aligned with the edges, exactly what you'd expect from compressed shocks moving through plasma. Another possibility is that ORCs are linked to jets from active galactic nuclei, AGN. Normally, when a galaxy's black hole launches twin jets, we see elongated radio lobes. But if one of these systems is viewed straight down the barrel of the jet, it might appear as a circular ring. The trouble is, many ORCs don't seem to have obvious central AGNs or optical counterparts, which makes this explanation tricky. A third idea suggests that galaxy mergers or titanic explosions in galactic centers could generate these huge rings. In such cases, the violent interactions might create spherical shells of energetic electrons, glowing in radio light. But again, the scale of energy needed is staggering, and the lack of supporting evidence in other wavelengths makes this far from conclusive. Adding more intrigue, the recent identification of glares, diffuse galaxies with large-scale ambient radio emission, hints that ORCs might not be one-off events, but instead part of a broader family of extragalactic radio structures. They could be connected stages in long-term galactic evolution, where outflows or shocks fade and transform over time. Why should astronomers, or anyone watching, care so much about these faint radio circles? Because their discovery isn't just about adding a new curiosity to the cosmic catalog. It represents an opportunity to uncover entirely new physics. First, ORCs could define an entirely new class of extragalactic objects. In astronomy, when a new class is confirmed, it often rewrites textbooks. Think of how pulsars and quasars changed our understanding of stars and galaxies. ORCs might be just as revolutionary. By existing outside known categories, they force us to explore processes we've overlooked or underestimated in cosmic models. Second, they serve as natural laboratories for studying cosmic magnetism and shock physics. The alignment of magnetic fields along ORC rims, as seen in polarization studies, provides a rare chance to probe how magnetic energy behaves over scales of millions of light years. This could help refine theories not only about galaxies, but also about cosmic rays and intergalactic plasma. Third, their discovery highlights the growing role of data science in astronomy. The fact that artificial intelligence can scan huge sky surveys and pick out faint, subtle rings proves how powerful machine learning is becoming for astrophysical research. The same tools used to find ORCs may soon reveal other unknown classes of phenomena hidden in sky maps. Looking forward, the prospects are thrilling. The upcoming Square Kilometre Array, ASKAP, the world's largest radio telescope under construction, will survey the sky with unprecedented sensitivity. Astronomers expect it will uncover hundreds, maybe thousands of ORCs, giving us the statistical power to test competing theories. Meanwhile, multi-wavelength campaigns using optical and X-ray telescopes will search for faint host galaxies or other signatures tied to ORCs, narrowing down what powers them. Odd radio circles began as faint, ghostly rings hiding in radio telescope data, and today they stand as one of the most intriguing puzzles in modern astronomy. They are vast, often millions of light years across, with no clear explanation in sight. Some may be shockwaves from ancient galactic eruptions, others linked to black holes or mergers, yet none of these theories fully capture the mystery. If you enjoyed this video, don't forget to like, share, and subscribe for more, and don't forget to leave a comment below. Thank you for watching, and see you next time.